Hello everyone. I apologize now for the length of this. There are 12 slides. I'll try to go through them as quickly as I can. We're going to start with reviewing a little bit about similar triangles. This whole lesson is about slope and the y-intercept. So it's intro to y equals mx plus b, which is the slope-intercept form. And we're going to talk about similar triangles as a way to help us find the slope. So what are similar triangles? What do you know about similar triangles? Well, one thing we know is that with similar triangles, all corresponding angles have the same measure. So if this angle corresponds with this angle, they have the same angle measure. We know that both of these are 90 degrees, and this one corresponds with this angle, and they have the same measure. The other thing that we know is that corresponding sides have the same, are in proportion. So corresponding sides are in proportion. So we can say that this height 3 and this length 4, or that base 4, is in proportion to 6/8. So this height, this base. So the side measures are in proportion. So we can test that by multiplying by 2, multiplying by 2. So they have that common multiple that we have been talking about. Or we could cross multiply, or we could reduce. So it has the same unit rate. So that whole idea of proportionality that we talked about in the last unit. So yes, these triangles are similar. So to talk about what we're going to learn in this new unit, in this unit we're going to be focusing on graphing and writing linear equations given different information. It's going to cover the Common Core Standards, EE 5 and 6, and Functions 4. So that is why a lot of this is in the functions part. So that's where I decided to house this unit, is in the functions unit. You're going to attach this to your learning target Math 8-6, use functions to model relationships between quantities, because that's what we're going to do. We're going to be using different ideas or different representations to model linear relationships. Alright, so let's get started with the material. We're going to be talking about similar triangles and using them to find slope. And we've already talked about slope. If you did the assignment from last week, you know about slope. But this is what we know. Corresponding sides are proportional. So for example, the height of this is 4, where the height of this one is 6, and this base is 2, and this base is 3. It stops right there. 3. So 4 is to 2 as 6 is to 3. They're proportional, and we can use that idea to find the slope of the hypotenuse. The slope of the hypotenuse is that ratio of the y change over the x change, just like in the last unit. The y change is 4, the x change is 2, that simplifies to 2. The y change is 6, the x change is 3, that also simplifies to 2. So it has that constant rate of 2. So I want you to remember what we know about slope. Slope, we talk about it as the y change over the x change, that ratio of the y change over the x change, or you can think of it as rise over run. How far do we have to rise and run? It's that ratio of using the legs of the triangle to describe the hypotenuse. This is another way to write it, the change in y over the change in x. This little triangle is the Greek letter delta, and it is a shortcut way of saying change. So the change in y over the change in x, that's slope. Okay, so one of your 10 marks assignments is specifically about slope and similar triangles. So here are some examples. So we are going to be looking at two similar triangles, right here and right here. And the question is, what is the slope of TP? It does not matter which triangle you use, you should come out with the same ratio of that rise to run, or the y change over the x change. So I'm going to make this bigger so we can see. So right here, this rise is 3 units, and this run is 1 unit, or this rise is 1, 2, 3, 4, 5, 6, 7, 8, 9 over the run of 3. So we have 3 over 1, or the ratio 9 over 3, and it comes out to that same unit rate of 3, or the same rate of change. It's not a unit rate anymore because it's not proportional. This relationship doesn't go through that origin like in the last unit, but we have a rate of 3, positive 3, so 3 over 1. So if we are going to answer this question, what is the slope? We could just say it is 3. Here's another example of a problem you might have today. So the longest, it's telling us they're similar and that the longest sides lie in the same line. So which statement is true? So the slope of UW, so this slope right here, is the same as PQ. Well, we know since it's on the same line that the slope is going to be the same. So we know this one is true. We know that it is not less than. The slopes are the same, so it's not that one. The ratio of corresponding sides of triangle UVW and triangle PRQ is equal to the slope. Well, what that means is corresponding sides, so UV and PR are corresponding. And when you are finding the slope, you are not looking at corresponding sides of similar triangles. You're looking at the rise over the run. So it's not that one. The ratio of corresponding sides, it's not that one. So the first one is the only one that is true. All right, one last example from that first 10 marks assignment. Triangles GHI and JKL are similar. We know they're similar. So therefore, we know that the corresponding sides form nice ratios. I'm going to do the side rise over run since that's what we're talking about. The rise over the run. The rise over the run. We know that these two ratios are proportional because they're right triangles that are similar. So now we can just solve that proportion like we did in the last unit. So we can use cross multiplication. So 9x is equal to, 12 times x minus 7. And we can solve that equation. So we are going to leave our 9x on this side. We're going to use the distributive property. 12x minus 12 times 7. So if you don't know that, you can write it off to the side, or you can use a calculator, or you can do 10 times 7 plus 10 times 2. Either way, we come up with 84. And we're going to bring the 12x over to get negative 3x equals negative 84. Divide by negative 3, divide by negative 3, so x is 28. So it is this one right here. The other way you could do this is think, okay, if this side is 12 and this is x, whatever this is, minus 7 is this, and it has to be in relation or proportional. So we could just plug these numbers in to see if it makes a true statement. Like, for example, 16. If this was 16, 16 minus 7 is 9. 16 over 9 is not the same as 12 over 9. So you know that one did not work. So if nothing else, if you don't know the setting up the proportion and solving equations, you could have just plugged numbers in to see if it worked. All right. In the last unit, we determined proportionality, and there was always, so in the last unit that we just finished, they were proportional if they had that 0, 0 relationship. So anytime we graphed, the line always went through that origin because of that 0, 0 relationship. So it's this line right here. It went through the origin, and we came up with the equation y equals 2x because our rate, we are going up 2 for every 1. We are going up 2 for every 1. For this unit, the graph line may or may not go through the origin. So we might have some that are proportional that go through the origin, but we'll just as likely have them that don't go through. So I'm going to make this a little bit bigger so we can see. So here we have our original y equals 2x, but we started, for this purple line, we started higher. From that we had to add 1, 2, 3, 4, 5, 6. So now it's not proportional anymore, but we know that from this we went up 6. Or we could do the same thing in the other direction. We went down 1, 2, 3, 4, 5. So we went down 5. So we have something added or subtracted to our main equation. So again, in the last unit, we determined proportionality. We were working with proportional relationships, so there's always that 0, 0 relationship. So when x was 0, y was also 0. Like here, when x is 0, y is 0. And then there was that proportional relationship where we found our rate, and it was always the same unit rate. So here, our rate was 5. In this relationship, when x is 0, y may or may not be 0. So for example, here, it is when x is 0, y is not 0. We can still see that y change over the x change. When y is going up 5, x is going up 0. So plus 5 plus 1. I said plus 0, but it's plus 1. So we can still see that plus 5 plus 1 plus 1. But we didn't start at 0. We started at 5 in this case. So we had our original y equals 5x, but we're adding to that 5 because we started at 5. So what's new in this unit is that the y-intercept, where we begin, where it crosses the y-axis, might not be 0. So we still have our original part of the equation, y equals mx plus b, where m is still that constant rate that we call slope. But now we're going to have something added or subtracted to it. So the slope is still the y change over the x change, rise over run, but now the y-intercept might not be 0. It's wherever it crosses the y-axis. It's what y is when x is 0. So in the last unit with proportions, when x was 0, y was always 0, but in this case it might not be. So let's just do some examples of the types of problems you're going to see on your 10 marks assignment. For this first one, identify the y-intercept. Well, the y-intercept is, remember, just where the line, the graphed line, crosses that y-axis. So we can look down, it crosses right there when y is -4, but we need to put it in a ordered pair form. So we know that the y is going to be -4. So we can cross out this one right away and this one because we know that y has to be -4. On the y-axis, x is always 0. We're not going to the left or right either direction. So it is going to be this one. When x is 0, y is -4. You will also be doing more practice with just finding the slope like you did hopefully with IXL last week. So again, I'm going to blow this up a little bit so we can see. And I'm going to find 2 points. Because the slope of any given line is always the same no matter what part of the line you're looking at, I'm going to just find 2 points where it crosses exactly. And this one is kind of tough. So it crosses right here and I think right here. So I'm going to draw in my right triangle and I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. So I went down 8 and over 1, 2, 3, 4, 5, 6, 7, 8, 9. So to find the slope, remember it is the y change over the x change, or the rise over the run. And here, my y change, I went down 8 and over 9, so negative 8/9. So I'm going to go in, and sure enough, we have that as an answer, negative 8/9. All right, last example from your assignment. So you have a graphed line, and this time you have to identify the whole equation and explain your answer. Well, I know the first thing I'm going to look for, the easiest thing to look for is the y-intercept. It crosses right there at a positive 3. So my y-intercept is a positive 3. So I'm going to look at these equations, and this says a negative 3, so I know it's not this one. This says, the third one says a negative 3, so I know it's not that one. So I'm down to 2 choices. Next, I'm going to look at my rate or my slope. So it is going up. So if it is going up, y is changing positive for every x. So that means my rate or my slope is going to be positive. And I can be more specific even. I can pick 2 points, up 1 over 1, up 1 over 1, or up 2 over 2, or up 3 over 3. Regardless, my slope is 1, not negative 1. If it was negative 1, it would be going downhill like that. So this would be my answer. All right, that's all I have for you today. Good luck with your 10 marks assignments, and let me know if you need help. We out.